Hello, we are back. We're going to talk about lesson 1.4, simplifying algebraic expressions. The essential question for the day is, how can I simplify and evaluate algebraic expressions?
And evaluate. Oh boy, oh, Miss Young, this is going to be a fun one. I can already tell. Evaluate algebraic
expressions. Excellent job.
Okay.
So now Miss Boyd's going to talk about some
just a quick review. If we're looking at these, you've done them before. We notice that AB is the exact same in both of these. So when they're the exact same, we just add the numbers in front. So since AB is the same, we put it here, and we add our numbers, 7 plus 3, and we got our 10. Easy. So same thing here. We have an A. That means we can combine them. So we do the 6 minus 8 to get our -2, and then the A goes back again. So
very good. Good job. Okay, so now example number 1. There are 3 different ways in which a basketball player can score points during a game. 1-point free throws, which we're going to label as variable A.
Okay.
2-point field goals, we're going to label as variable B.
So just a 2-pointer.
And 3-point.
So as 3-pointer from behind the line.
Correct. Label it as C. So now Miss Boyd is going to write an algebraic expression that will represent the total points scored during a game.
Okay.
So the algebraic expression then would be A.
So, because really you could have a 1 out front.
You could.
But we don't need to do that.
Plus 2 times B.
Okay.
Because they're 2-point field goals.
For every field goal.
Plus 3 times C.
Okay.
That is an expression.
Because there's no equal sign.
No equal sign.
Got it.
So now if we go on to the next screen, we're going to continue on with example 1.
I'm going to write that that expression up here again.
Great.
So I'm going to do A plus 2B plus 3C, just so we have it.
Very good. So now we're going to write an equation.
So equation always has an equal sign.
Yep. For a game where 72 points were scored.
So that's our total. We want it to equal 72.
And on the left, it's going to be?
You just write this equation down again.
A plus 2B.
Oh boy. B.
Plus 3C.
All right.
There we go. Now, let's finish. If there were 25 2-pointers.
Okay. So 2-pointers were our B's.
Yep. And 5 3-pointers. 3-pointers were our C's.
We're just going to be plugging it in.
How many free throws were made? And the free throw was our variable A.
So we want to find out what A is.
Let's plug it in.
So we leave A, because that's what we're trying to find.
Plus 2.
And like I said, we just plug it in for B.
Yep.
So 25 plus 3. And we said there were 5 3-pointers.
Correct.
And it equals 72.
And now we're just going to go through and do the math.
Equation.
Yep.
So we've got the 50 here, plus the 15. Don't forget to bring the A down.
Correct. Equals 72.
Combine these.
Yep.
So we got A plus 65
is equal to 72. And subtract 65 on both sides.
Perfect.
And when we do that, we get A is equal to 7.
Nice.
And there's our answer. There were 7 free throws.
Sweet.
So now we'll go down and we're going to talk about order of operations.
All right. So we've kind of talked about this a long time ago. You guys know this. But just a reminder, PEMDAS. So when you're solving an equation, you always want to do the order of operations. So first, anything with a parentheses. So that's where our P comes from. Then an exponent, so like something to the 3rd power or 4th power. So now we have our E, and then multiply and divide. Those go multiply, divide, but if by chance you had division before multiplication, you would do that first. It's from left to right. So that's how we read it, and then add, subtract. Same thing, left to right. So maybe a subtraction comes before an addition, that's fine, do that first.
And we're going to use order of operations in our next example.
Sweet.
Here we go. So we're going to evaluate the following. Notice you're given an expression and you're saying substitute X for 5 for X, and then 2 for Y. Perfect. So let's do that right now.
Just go in there.
Correct.
These would go here.
Everywhere there's a Y, yeah.
And here. Okay. So I'm just going to write that. Oh, I forgot that other X.
There's one more arrow. There we go.
All right. So 2 instead of X, we're putting 5. minus, instead of x, we're putting 5. Instead of y, we're putting 2. See how I do parentheses just to make sure I'm not confusing myself?
Right. Everywhere Miss Boyd is
4.
substituting something in for a variable, she's putting that number in
So
parentheses.
instead of y, I'm going to put 2.
Correct. There we go.
All right. Now we can solve that.
Right. So now let's make sure we do PEMDAS.
Okay.
So what's in
is there
parentheses?
There's
Well, that's not,
included.
Is there any exponents? No.
No.
But there's multiplication.
Multiply.
So 2 times 5 is 10 minus, and then 5 times 2 is 10 plus 4 times 2 is 8.
All right.
Now we're left with adding and subtracting from left to right. Correct. So 10 minus 10 is 0 plus 8.
Plus 8. Well, we just get 8.
And we're done.
Nice.
So let's go down to example 3. Same thing.
All right.
Let's do our substitution.
So instead of q, I'm putting in 7.
Yep.
Again, I'm putting in parentheses so that I don't get confused.
Right.
Plus 4 times q is 7.
And r is 3.
Minus r is 3.
And squared. Okay. So we go through PEMDAS again.
Yes.
Parentheses, well, not
Nothing
really.
adding or subtracting inside the
Right.
parentheses.
Exponents. Yes, there is.
We
So
got
7
49.
squared is 49.
And
3 squared is
9.
So we can take care of those.
All right. Now we bring everything else down.
Yep.
So plus 4 times 7 times 3 minus the 9.
Correct. Now we do a multiplication. So we know that 4 times 7 is 28 times 3. We'll just write that right now. And that is 84.
84. Awesome. All right. And I'm going to bring everything else down.
So we bring
So
down
I'm
the
bringing down
49.
49. It had a plus sign in front, so I'm adding it. And then I'm bringing
minus
down
9.
the minus 9.
Add and subtract from left to right.
Left to
So we
right.
know that 49 plus 84, that's 133
3.
minus 9, which is 124.
Sweet.
And we're done.
Awesome.
All right, let's move on. Example 4. I think at this time we are going to
We'll just
skip.
it.
We're
You
going to
can
do
try
in
it if you want,
class.
but we can do it in class.
Now we're going to go over like terms and constant terms, and basically it's really what Miss Boyd said at the beginning of the lesson. Notice the 3x squared and the 4x squared. The x squareds are the same. When that is the case, you add the coefficients in front. 3 plus
Nice.
4 is 7. So why don't we just get going and do an example?
Yeah.
All right, example number 5 we are on right now.
All right.
So,
I'm going to go through
Go ahead.
first, and I'm going to look at things that are the same.
Yep,
So I see that this is an x squared, here's an x squared. All right, that's all my x squareds.
yep,
Now I've got an x. Here's an x.
Correct.
And
That's
xy
it.
is different. So my xy is by itself.
there we go. And we color coded it for you.
Yeah.
So we notice that 3x squared and 2x squared, they have the same x squared variable. So we're going to add 3 plus 2, which is 5. And x squared says x squared.
Yeah, we just bring it down.
Yep.
All right.
Now we have negative 5x plus 7x.
Yes, don't forget that. negative.
So negative 5 plus 7 is 2. So it's plus
So positive 2.
2x.
X.
And then the 3xy minus 3xy just gets
By
brought
itself,
down.
we just bring it down.
And we are done.
That's your answer. So notice that you're not going to get one final number as your answer when you're
Correct.
simplifying. You're still going to have x's and y's. in
Like we did before when we would substitute a number in for a variable. We're not doing that here.
there. Okay.
Example number 6. Let's do the same thing. Let's color code.
All right. So I got x squared. Oh, here's another
Yeah.
one.
And we have
I
an
got
x. And we have
we have a y.
There we go. So
All
this
right.
one's pretty straightforward. So we
Yeah.
know that 3x squared plus 4x squared,
Gives us
7x squared. And then we just bring down the
just have to put on the other
2x
things.
plus
Oh, that's
2x
easy enough.
minus 3y. And we're done.
We're done.
Let's go down to the next one. This one now, we're using a property,
Yeah.
and that property is called the,
Distributive property.
you got it. So let's
we gotta
do
take
that
this J.
first.
And we got to distribute it to both things.
And we're going to say right now, the best way to take care of this, if you're unsure if you should put the K before the J or the J before the K, always put them in alphabetical order.
Okay.
So in this case, J is going to
comes
come
first.
before K.
Okay.
So go
we have
ahead.
our 6. J, well, since you said put it first,
Yeah.
we have J, K squared.
Mhm.
JK.
JK, I like it.
All
Plus
right.
7
7
JK.
JK. All right, now we can copy everything else down because we got rid of the
Correct.
parentheses like PEMDAS tells us
Yes.
to. All right. Now, this is when we look for similar things.
Yep. So let's color code.
So, we have a JK squared.
And a
and
JK squared.
And we're not kidding.
No, we're not. You may wish we
a
were. A JK and a JK.
And a JK.
So let's combine now. So we have 6 plus 9 is 15. JK squared.
JK squared.
And notice what happens to the 7JK.
Positive JK
and a negative JK makes.
They cancel each other out.
0 JK, which is just 0.
We're done.
That's it.
All right.
So now let's go on to the next page. And we are going to skip example 8. Let's do that in class.
Perfect.
So now we have a word problem.
Ooh, I don't like word problems.
Yeah, you know.
It's okay.
It's all right.
Work through it.
We'll make it.
Thanks.
Okay. So apples cost $2 per pound and grapes cost $3 per pound. We are going to write and simplify an expression. Notice expression.
Not an equal sign.
For the total cost if you buy 10 pounds of apples and grapes combined.
Okay. So since they're combined, we don't want more variables. We just want one variable.
One variable. Okay. So I say, let's start with A. Let's call A our number of pounds of apples.
Okay.
That's our first variable. So A is going to go with apples.
Okay.
And if we know we're buying a total of 10 pounds of apples and grapes, well, we can define grapes in terms of A by taking 10 minus A.
Oh, yeah. So however many apples, we just take it away from the A, and then we'd have our leftover grapes.
Correct. So we know we have a total of 10. Let's take away the apples, and that's what's left over for grapes. Okay. There we go. So now we're going to write an expression. Well, we know apples cost $2 per pound.
Okay, so $2
times A.
4 apples.
Right.
Okay.
Plus $3 for grapes times.
And we said the grapes is this whole thing. So I'm going to put parentheses 10 minus A.
Now, we could be done, but we said simplify.
Yeah,
so we have to keep going.
So we can distribute.
Correct. So let's do that.
All right. So we still got the 2A. Plus 3 times 10 is 30. Minus 3A is, 3A.
Yeah.
Okay.
And now we can combine our like terms. So we know that 2A minus 3A is just, you can write negative 1A, but we typically don't do that. We just write negative A.
Plus 30. I like to put my numbers first.
I do too.
Can leave it. So I have 30 minus A as my final answer.
And we probably, I know we're using lowercase here, but I think we should probably, let's fix this. We should stick with uppercase because otherwise you may get confused. Why did Miss Young and Miss Boyd switch all of a sudden to lowercase?
Good call.
It doesn't matter. We started with uppercase, so we should stick to it. There we go. Now
so that's our expression.
That's our expression. Now it's saying, what is the total cost if 2 pounds of the 10 pounds are apples? They just told us what A is.
Yeah.
A, remember, is apples, the number of pounds of apples. We know now A is equal to 2. So let's write A equals 2.
I'm going to plug that in. So A equals our 2.
And
we're going to write our expression.
Yep. 30 minus A.
And now we're just plugging 2 in for A.
That's it.
So we got 30 minus 2 equals
$28.
Sweet.
Because it's the cost. Nice. And that is it. So let's go on. Here are your video questions. Please work through those, and we will see you tomorrow.